Hi everyone, so this is your first piece of home learning for physics. It's the basics of electricity, and basically we've set it because a lot of this information you like to write down and highlight and have for your notes, but it takes an awful long time to go through, and so we would like to spend the time with you in lesson doing some model questions and things which are a bit harder. So it's really important that you, from these slides, pause me every now and then, write down what you want to write down, and then anything you don't understand from the slides, you can then talk to your teacher about. Okay, so we're going to begin with current. So the definition of current and what it is. So current is the flow of charge through a substance, such as a metal or a solution. So in a wire, current is the flow of electrons, and they have a negative charge. In an ionic solution, which is something you come across more in chemistry, you have both negative and positive charges, and they both move. Okay. In something like a proton beam, protons are positive, so it's the positive protons which move. At GCSE physics, you're going to be mostly interested in the electrons. Now, current is measured in a circuit with an ammeter, which you would have used before in Year 8, and its symbol is strangely an I, and people always ask me, why is it an I and not a C? Well, when current was discovered and explained, the person who found it or discovered it was French, and so he called it intensité de courant, and so that's where the I comes from. So the current is measured in amperes, so that's the unit of the current, and Ampere was the scientist who discovered it, who was talking about before. We often say amps for short, and the symbol for amps is A. So if we're thinking about our literacy and how we would be talking about current, and an example is if you wrote down I equals 3A, such as I've done on this slide, that is exactly the same as saying the current is 3 amps. So the I means current, the 3 is obviously 3, and then the capital A is amps. How should we think about current then? Well, a really handy model to imagine when you're thinking about current is water flowing through a stream or a river. So if you have a look at the image, okay, the wires would act as the sides of the rivers, so these parts here. And then the flow of the water would be the flow of electrons through the wire. It's a really good analogy to use, and when you're looking at a problem, it's a really good way of thinking about current, but it doesn't work in every situation. Sometimes it doesn't help you think about other aspects of electricity, but if you're just thinking about current, it's a really good place to start. Okay, we're now going to look at potential difference. So potential difference is a measure of the electrical energy being carried through the circuit by the charge, so the electrons. So it's how much energy basically are they carrying around the circuit. And when you're measuring potential difference in a circuit, you're effectively measuring the difference between the electrical energy at one point and the electrical energy at the other point. So for example, that could be one side of a bulb and then the other side of the bulb. You're measuring the difference in electrical energy between those points. Okay? And there is a difference because the bulb will use some of the energy. So the difference in potential gives you an idea of the amount of energy being used. Now, it's not exactly energy because it's not measured in joules, but it's related to energy because it's how much energy there is per unit of charge. So it's about how many electrons there are and how much energy they're carrying. And we'll do that more in lesson because that's a little bit more difficult to understand. So potential difference is measured in a circuit with a voltmeter. Okay. Its symbol is capital V, and as it's sometimes referred to as voltage. It's measured in volts, and the symbol for volts is V. So a little bit easier to understand than current because both of the symbols are capital V. So if you're thinking about literacy and how you're going to say it, if you saw written down V equals 3V, that's exactly the same as saying the potential difference across the bulb is 3 volts. Okay? So let's think of a model about how to think about potential difference. So you need to change your view of current in this. So rather than thinking about the water, I want you to think of them as vans. I know that sounds a bit weird, but they're a van, okay? And they're driving around a circuit. Now I want you to think about the cell or the battery as a bakery making loaves of bread, okay? So the cell or the battery is providing the vans with bread. And in this case, we're going to think of the bread as the electrical energy, so their voltage, okay? So the cell or the battery provides that. So the cell, if it's a big cell, it could provide really big loaves, or if it was a small one, it might provide smaller loaves. That's how we're going to think about it. Now, the vans get loaded up at the bakery with all the loaves, so they have the potential to deliver them. Okay, so the loaves are the voltage. So when they get loaded up, the vans have the potential to deliver the loaves. When the vans then go out and deliver the loaves to the houses around their circuit, then they will then give their loaf to a house, and then that house then has some voltage or some energy, but the van is now empty and it needs to go and get refilled. So if you measure the voltage before they deliver and after they deliver, there is a difference, okay, and therefore a potential difference. And I've got an image to try and show that. Please excuse the crudeness of this because I couldn't make it animate properly, so I'm just going to move it myself. So here's your bakery. The bakery is going to load up the bread van with a loaf, okay? We're then going to move the bread van around the circuit with its loaf, and then it gets to a house. At the house, the bread van will deliver the loaf, so it will give it to the house. It will now be empty, and it needs to move back round to the bakery to be filled up again. So there was a difference in the ability to deliver energy here, because here it had the loaf, and then here it didn't have the loaf. So there's a difference in potential. When it goes back round to the bakery will then give it some more bread, and it has the potential to deliver that voltage again. If you're not sure about that, because potential difference is a bit harder to think about, ask your teacher in your lesson. The last couple of things I want to talk about here then are resistance. Now we will do a lesson on resistance, but just so you know, it links with current and potential difference. So the resistance in a circuit forces the electrons to give up their voltage, so therefore creating a potential difference. So what the resistance does is as the electrons flow through, it makes them give up their voltage. So when the current flows through something with the resistance, the electrical energy is then converted into other forms, e.g. in a light bulb that would be heat and light. The light bulb forces the electrons to give up their electrical energy and turns it into heat and light. Now the symbol for resistance is R, and resistance is measured in ohms, okay? And the symbol for ohms I have not put on here, so I just need to pause it and I will add it in. Okay, so there we go, I've added the ohm symbol. So you can see it looks like a head with little shoulders coming off. Okay, so that's the symbol for ohms. Resistance was discovered by a scientist called Ohm, and so that's his symbol that he uses. Okay. Right, the very last thing I want you to do then for this home learning is, these are the circuit symbols. So open switch, closed switch, cell. So what you would call a battery in, let's say, like a remote control or whatever, is actually called a cell. So cells have 1.5 volts, and one of them is called a cell. If you have more than one, then you call it a battery. So you can see the cell and the battery symbols are really similar. It's just that if you drew two of them, that would mean two cells, and this dotted line in the middle means more than two. So you might put the voltage above to show how many volts it is. You need to make sure that there is a long side and then a short side, and then a long side and a short side. So the long side is the positive side, and then the short side is the negative side. We then have a diode, which we will be doing about in another lesson, learning what it does, a resistor, a variable resistor, a lamp, a fuse, a voltmeter, an ammeter, a thermistor, and what's called an LDR, which is a light-dependent resistor. You need to draw these symbols down, and you need to know them so that when you reuse them in lessons, you know what they are. Okay, as I've said before, any issues with any of what's been taught, write down the information in your book, highlight it, and then you can talk to your teacher about the bits that you didn't understand. Thank you.